Hello everyone, I welcome you all to my channel Revealing Concepts. In today's video, we are going to know about a topic known as basis of a vector space under the main topic of vector space only. Again, this is a very important topic under the chapter of vector space, wherein we would be knowing how to find or how to prove whether a given set is a basis for that particular vector space. So here is the definition, and following are some notes that are given. Depending upon these three notes, we are going to solve these three problems. So the first note is corresponding to the first problem, the second note to the second problem, and the third note to the third problem. So har ek note use karke we are going to solve these three problems that are there. So let us start by knowing what is exactly known as the basis of a vector space. Basis जो होगा वो एक set ही होगा. It would be a subset of a vector space, but it has to satisfy two conditions in order to be called as basis of the given vector space. तो वो दो conditions यही है कि the given set which we are going to show as the basis should be first linearly independent set, and second, your V should be spanned by that particular set, meaning every element of the vector space should be returned in the linear combination of finite number of elements of the given set, which you are supposed to prove to be as the basis of the vector space. तो अगर आप वो set linearly independent show कर सकते हो, and at the same time you have to also show that your linear span of S is equal to your V, meaning your V is spanned by the particular given set S, then we can say that the set S, which consists of certain vectors from the given vector space, is basis of the vector space that is given to you. So whenever you have been given any problems, you just have to show these two conditions satisfy, and hence the set is a basis. If either of these two conditions fail anywhere, then that the given set wouldn't be called as the basis of the vector space. So now here are certain important notes which you can directly use while solving problem. सबसे पहले यही है कि when I say standard basis, इसका मतलब कि just like we have the standard form of any particular linear equation or a polynomial, like that the standard form for the basis of a vector space Vn over the field F is given in this form. So this is basically एक ऐसा collection of vectors है जो n tuples के set है. Basically this is a set of n tuples of vectors. So if you see, this is the standard basis for the set for the vector space Vn over the field F. If more precisely to understand what exactly is given, अगर आपको बोला है कि एक vector space दिया है which is two dimensional, that is let's say R2 over R, the space of real numbers over the field of real numbers. So R2 over R मतलब two tuple वाले जो होंगे उसमें vectors रहेंगी. So if we are talking about any vector space of two dimension over any field, तो उसका जो basis होगा उसका form होगा 1, 0 and 0, 1. इससे basically हम entire vector space को generate कर सकते हैं. क्यों? क्योंकि ये linear span बन सकता है. At the same time, it should be linearly independent also. So this is the standard basis for a vector space of two dimensions with the over the field F. वैसे ही अगर हम V3 of F के लिए अगर standard basis बोलेंगे, then that would be 1, 0, 0, 0, 1, 0 and 0, 0, 1. So these are the three vectors that would form the basis for, let's say, a vector space of real numbers, that is R3 over R. Now the next note is, again we are going to show how exactly this is true, but henceforth you are going to use this in order to solve your problems directly. Let's say कि आपको कोई set of polynomials या vector space ऐसा दिया है जिसमें सारे vectors polynomials हैं. So here they are saying that 1x, x square and so on up till xn is the standard basis for the set of polynomials of degree n over f. So if there is a vector space जिसमें there are polynomials that have been given to you, then for that particular vector space the basis would be 1x, x square and so on up till xn. And the final note for today's class is any subset of Vn of f have more than n elements will be linearly dependent and hence cannot form the basis of Vn of f. What does this mean? कि लेट्स से आपको Vn of f एक वेक्टर स्पेस है, n डायमेंशनल वेक्टर स्पेस, उसका एक सबसेट दिया है एंड लेट्स से कि दैट सबसेट इज हैविंग मोर देन n एलिमेंट्स. Okay, let's say it has got n plus 1 or n plus 2 elements, right? And we already know कि अगर एक आपके पास सेट है, right, and if you are getting one more set which is bigger than this set, when I say bigger it means कि इसमें इससे ज्यादा elements है, इसका मतलब the extra elements can be expressed linearly in terms of the other remaining elements, and that is why we can say कि ये जो set है that is not linearly independent, it is linearly dependent. और since ये जो बड़ा वाला set है ये linearly dependent है, इसकी वजह से we can say कि it cannot form the basis of the given vector space because the first condition for the set to be vector space is कि it has to be linearly independent, and अगर वो linearly dependent है because of those extra elements that are there in that particular set, we can say कि वो उस set का basis नहीं form करेगा. Of course that set is going to span the vector space but it is not going to be the basis क्योंकि वो linearly independent set नहीं होगा. So whenever आपके पास कोई question होगा which is like the third question, here it is said कि ये एक set है, and we would come back to this question but just show that कि ये एक set है, it spans R3 but it is not the basis of R3. R3 here n is 3 but if you see the number of elements in S are 4. So your questions like these could be easily solved or directly solved using this particular note. You just have to give the reason as to why you are saying so. ठीक है? So now let us start with solving the problem. The first one, as I told you, is corresponding to the first note. Standard basis का एक problem है वो, which is easy also. It says that you have to show एक set दिया है, set S, and it consists of two vectors in tuple form, two tuple form, 1, 1 and 0, 1. Of course, this would be the subset of the vector R2 over R, right? Now you have to show that S जो है, to show your S is the basis of R2 over R. If we are supposed to show that S is the basis of R2 over R, इसका मतलब we are supposed to show these two conditions. So first one, we will say to show S is linearly independent. So to show that S is linearly independent, we are going to take the linear combination. So consider A and B belonging to R such that, take the linear combination A 1, 1 plus B 0, 1 equals to 0, 0. Now let us see whether we get the value of A and B as 0 or not. So yeah, we get A and then we get A plus B equals to 0, 0. यहाँ से we get A equals to 0 and A plus B equals to 0, which implies your B is also 0. So here if you see, your A and B both are zeros, and that is why we can say कि S is linearly independent क्योंकि जो coefficients मिले हैं they are turning out to be 0. Now second part is you have to show that linear span of S is equal to V, meaning your V is spanned by the set S. So clearly we know, this is something that you have to show. Clearly we know that हमारा जो L of S है, that is of course the subset of the vector space R2 over R, right? Now we have to show, this is the trivial or the default thing that exists. Now we have to show R2 over R is a subset of linear span of S. तो उसके लिए I would be taking an element x, y belonging to R2 over R such that there exist A and B belonging to the set of real numbers. ठीक है? Now what we are going to do is we are going to express this particular xy in terms of the vectors that are given to us. Okay, so let xy belongs to r square over r such that there exists a and b in r, and your xy can be expressed as a into 1 comma 1 plus b into 0 comma 1. Now what is our aim? हमारा aim यही है कि what we are going to do is we are going to show कि xy जो है that can be expressed in terms of these two vectors which are nothing but the set S, and अगर हम xy को इस terms में express कर सकते हैं in the linear combination of the vectors of set S, इसका मतलब क्या है? That this particular element xy it belongs to the linear span of S. Right, because if you remember the definition of linear span, it says this thing only. If you have not watched that video, I request you all to visit my channel. There's a playlist called Linear Algebra. Under that we have covered the topic of linear span along with examples also, so you will get to know what exactly it is. So I request you all to please watch that. So यहाँ पे if I show कि xy अगर इनके terms में linear combination of 1, 1 and 0, 1 के terms में अगर हम express कर सकते हैं, then your xy belongs to the linear span of S. Now for that we need to show कि a and b के legit values exist करते हैं, right? So उसके लिए now we are going to solve this resultant equation for the values of a and b. Let's see कि a and b exist करते हैं या नहीं. So now here if you try to do the component wise addition, we get a comma a plus b. कंपेयर करके हमें a की वैल्यू x मिलती है, y equals to a plus b. So this implies your b equals to y minus a, which in this case is y minus x. ठीक है, so यहाँ से हमें a की वैल्यू x मिलती है, b की वैल्यू y minus x मिलती है. What are these x and y's? These are the components of the vectors that I have taken from the set of R2 over R. तो अगर मैं कोई element लूंगी, I just have to substitute those values, and for those values I'm going to get the corresponding coefficients, and hence I can say कि this implies your x and y it can be expressed as the linear combination of a and b, as the linear combination of 1, 1 and 0, 1 with the coefficients. So I can write it as in this manner. अभी जो वेक्टर हम x and y लेंगे उसी का वैल्यूज तो यहाँ सब्स्टिट्यूट करेंगे तो प्रॉपर आंसर तो हमें मिलेगा. एंड सिंस वी आर गेटिंग अ प्रॉपर आंसर, आई कैन से कि योर xy it belongs to the linear span of S, and that is why your vector space R2 over R is equal to the linear span of S. This is from 1 and 2. ये equation 1 है, ये equation 2 है. And so we have shown कि S linearly independent है and your linear span of S is equals to V. Therefore, the given set forms the basis of the vector space R2 over R. This is how you are going to show कि कोई भी set किसी भी vector space का basis कैसे बन सकता है. Right, now next one is 1x, x square and so on up till xn. This set of n plus 1 polynomial is basis for the vector space fx of all polynomials of degree n over the field f. Now here if you see, degree is n but the elements are n plus 1 because x raised to 0 भी उसी का part होता है degree n polynomial का. So don't get confused with the third note and the elements that are given to you. So here also first we are going to show कि जो set है that is linearly independent, that is the coefficients that we are going to take, they are all simultaneously equal to 0, and then we are going to show कि एक element होगा vector space में, it is in the linear span of the given set, that is the linear combination of the given set. So question 2. We are going to consider the set that is given to us, which is S equals to 1, x, x square and so on up till xn. ठीक है. नाउ वी आर सपोज टू शो कि fx जो है ये सेट S इज द बेसिस फॉर द सेट fx. ठीक है. सो टू शो set S is the basis of fx. ये set vector space of polynomials है. Okay, over the field f. So now the real solution starts here. First, to show S is linearly independent. So consider A1, A2 and so on up till AN belonging to the field. We don't know what the field is. Okay. Now we are going to take the linear combination of these elements along with the coefficients. So we will say A1 into 1 plus A2 into x plus A. So we will start from A0, not A1. This is A0, A1, A2, x square plus and so on, an x raised to n equals to 0. Now this 0 can be written in terms of the polynomial again. So can I write 0 into 1 plus 0 into x plus 0 into x square plus and so on 0 into x raised to n. ठीक है. Now if I compare both the sides, what can I conclude? Can I say that your A0, A1 and so on up till an are all simultaneously equal to 0, and that is why your S is linearly independent. Second point, to show that your linear span of S is equal to V. Clearly L of S जो है it's a subset of the vector space fx, क्योंकि वो polynomial का ही set है तो vector space का तो subset होगा. Now you have to show कि your fx is a subset of the linear span of S. उसके लिए you're going to take an element. So you're going to say let you take a polynomial for this set. Now and you're going to see whether you can express that polynomial in terms of this set or not. ठीक है. So you take a polynomial which is of the form b0 plus b1 x1 plus b2 x2 plus and so on bn xn. Okay. Now if I compare this and I see clearly, if you see, I can write this as b0 x0 plus b1 x1 plus b2 x2 plus and so on bn xn. If you see, you have expressed already the given polynomial in terms of the elements of the set S, and that is why we can say कि your fx belongs to the linear span of S, and this implies कि your capital Fx जो vector space है that is a subset of linear span of S, and that is why from 1 and 2, where this is your 1, this is your 2, ये 1 and 2 से we can conclude कि your linear span of S is equals to f of x, and hence we can say, we can finally conclude कि ये जो set है it forms the basis of fx. Right? Now let's move on to the third note, जहाँ पे you have to keep in mind कि जो भी vector space आपको दिया है, अगर basis में उससे ज़्यादा elements है, उसके dimension से ज़्यादा element है, then you can say कि वो set उसको span कर सकता है. You can show that it spans, but it is not the basis, because the set itself is not linearly independent. It is linearly dependent. And for that you can directly just mention कि since the dimension of the given vector space is less than that of the number of elements that are there in the basis set, hence it does not form the basis of the given vector space. But उसके पहले let us understand what exactly the question is asking. You have to show कि ये जो set है S जिसमें 4 elements है, it spans R3, बट इट इज नॉट द बेसिस ऑफ R3, वो R3 का बेसिस है नहीं, ठीक है. सो अगेन इफ यू वांट टू शो कि इट स्पैन्स R3, इसका मतलब यू हैव टू टेक एन एलिमेंट फ्रॉम R3, यू हैव टू शो कि वो एलिमेंट जो है that can be expressed in the linear combination of these elements. एंड अगर हम लीनियर कॉम्बिनेशंस लेंगे तो हर वेक्टर के करस्पॉन्डिंग एक कांस्टेंट रहेगा, उस कांस्टेंट की वैल्यू एग्जिस्ट करती है या नहीं. सो फॉर दैट वी आर गोइंग टू शो दैट टू शो कि लीनियर स्पैन ऑफ S इज इक्वल टू R3. ठीक है. अगेन the trivial one is clearly we know कि ये जो linear span हमें दिया है ये तो R3 का subset है ही. Now we have to show कि R3 is a subset of linear span of S. So you take an element which is nothing but let's say x1, x2 and x3, a three tuple that belongs to the space R3. ठीक है. Now you express this x1, x2, x3 as the linear combination of the vectors that are given to you. So let's say this is A1, 0, 0 plus B1, 1, 0 plus C1, 1, 1 plus D is your fourth vector 0, 1, 0. ठीक है. Now you are going to calculate or you are going to see whether the values for A, B, C, D exists or not. तो उसके लिए let us first simplify. So component wise यहाँ से A plus B plus C is the first component. Second is B plus C plus D is the second component, and third component is just D. No, it's just C. ठीक है. So x1, x2 and x3. यहाँ से अगर हम कंपेयर करें, here if you see A plus B plus C, let us just verify once, then we get A तो यहाँ पे नहीं है, B plus C plus D, ठीक है, and finally just this coefficient C. So यहाँ से we can say कि your A plus B plus C equals to your x1, B plus C plus D equals to your x2, and C is equal to your x3. ठीक है. Now we know C is equal to x3. Can I substitute it over here? Yes, and I will move on the other side. So I'll get B plus D equals to x2 minus x3. अभी already B ये जो है दिस इज बेसिकली लेट्स से हमारे पास ये दो वैल्यूज है ऑलरेडी एंड वी जस्ट डोंट नो B and D. So what I will do is I'll take some value for B and I'll get the value for D. So let's say x2 and x3 हमें पता है तो इसमें से कोई वैल्यू हम लोग ले लेते हैं. So I'll take the value of B to be x2. So let B equals to x2. This is randomly you can take out of x2 and x3. ठीक है. I have taken x2. So I get D का value as minus x3. अगर D minus x3 मुझे मिलता है then if I substitute it over here, okay, can I get the value of B? I get the value of B as x2, right? So यहाँ से now what I'll do is I'll just substitute these values and I'll get the value for x1. So A जो हमें मिलता है in this case, if you see, are we getting the value of A from anywhere? No, so we will find it from here. Here if you see B का value हमें अभी मिला है x2, write A as it is. B का value is x2, C का value is x3 and x1 is as it is. So this implies your A becomes x1 minus x2 minus x3. So here if you see clearly, हमें A का वैल्यू मिला x1, x2, x3, हमें B का वैल्यू मिला x2, मतलब हमने x2 लिया और वहां से हमें D का वैल्यू माइनस x3 मिला एंड C का वैल्यू इज x3. ठीक है. सो नाउ वी जस्ट हैव टू सब्स्टिट्यूट दिस वैल्यूज ओवर हियर. सो हमारा x1, x2 एंड x3 कैन बी रिटर्न एज A के जगह पर वी आर गोइंग टू राइट वी गॉट A एज x1 माइनस x2 minus x3. ठीक है, multiplied by the first vector. Now next first vector as in 1 0 0, then we are going to write the value for B. We have got B as x2, write the second vector. Then C ka value we have got x3, write the third vector. Plus what is D ka value? We have got it as minus x3, write the fourth vector. So here if you see, we can express x1, x2, x3 in the linear combination of these four vectors that are given, such that the values for these coefficients they exist. ये find out करने के बाद, if you remember the video for the lecture that was taken for linear span, वहाँ पे मैंने दिखाया था कि once you get this, you also have to verify कि ये solve करके वापस हमें x1, x2, x3 आता है या नहीं. So that is up to you. You have to verify कि आता है या नहीं. If it is not coming, it means that I have done some mistake. So you can post it down in the comment section. So ये करना है. Now once you have done this, you can conclude that the set S spans R3, or you can say कि your L of S is equals to R3. But now the main question is you have to show that it's not the basis of R3. So we can say that dimension of R3 is equal to 3, which is less than the number of elements of basis set, which is equal to 3. And this implies that S जो है is linearly dependent, which implies that it does not form the basis. So here if you see, this is how you can conclude कि ये जो particular given set है that is not the basis, because जो set दिया है वो ultimately linearly dependent हो जाता है because of the fact that the number of elements that are there in the set are greater than the number of elements or the dimensions of the given vector space. So I hope you all have understood what has been taught in today's video. Again, I would say that if you haven't watched the previous videos, which covers all the basic concepts related to linear algebra, please do visit my channel and watch those videos. You would get an overall understanding of what actually goes into the topic under vector spaces. And if you have any doubt with regards to these topics, you can post them down into the comment section. Thank you so much and see you soon in the next class.